To understand representations of solutions, make sure you have a strong understanding of solutions and mixtures, the video which comes right before this one. The only new thing we're introducing in this video are particulate models to represent solutions on the molecular level. This sounds complex, but all it means is that we're drawing pictures of what our solutions look like atomically. These drawings will show the molecules in our solution, their relative concentration to one another, and their interactions with one another. Let me demonstrate this by drawing the particulate model for the dissolution of NaCl in water. I have here a flask, which is neither half full nor half empty, and I'm going to fill it with water. I'm now going to take a cube of NaCl and put this in my beaker. If you don't remember exactly what's happening on the molecular level when water dissolves a salt, that's fine. I have a full video on this. I think it's called Ionic Bonds Part 3 on my channel. So if you're interested in learning more or refreshing up on that, I recommend watching that. But what you do need to know is that this ionic solid will dissolve, and in its place, we will be left with free-floating sodium and chlorine ions. Pay close attention to the fact that I've drawn my chlorine ions larger than my sodium ions. This is because a chlorine anion gains an electron and a sodium cation loses an electron. So chlorine will have a larger electron cloud. It will be the bigger ion. It's also super important to notice that I've drawn 3 chlorine ions and 3 sodium ions. Sodium chloride dissolves in a 1-to-1 relationship, meaning I get an equal amount of sodium and chlorine whenever I dissolve sodium chloride. Because the problem specifically stated that I should be drawing water molecules, I have to do that as well. When drawing your water molecules, it's really important that you make sure they are oriented in the correct way. All the negative portions, or the negative oxygen in my water molecule, are attracting towards the positive sodium ions. And all the positive parts of my water molecule, my hydrogens, are attracting to my chlorine ions. So again, if you forgot how to do that, I have a video on this. But just make sure you're drawing those orientations correctly. Otherwise, you will miss points on the FRQ. Additionally, an FRQ will usually tell you how many water molecules you have to draw, so just make sure you're following those instructions. But so this right here, my free-floating sodium ions, my free-flowing chlorine ions, and my water molecules attracted with correct orientation towards these ions is how I would draw the particulate representation for NaCl dissolving in water. Let's do that again, this time with a little bit of a harder question. Okay, so this problem reads, draw the particulate model for the dissolution of silver nitrate in excess, table salt, and water to form AgCl. The formation of silver chloride is represented by the above equation. Do not include water molecules in your depiction. So let's dissect this. First of all, I'm drawing a particulate model. Just make sure you're always reading your question, being aware of that. I am dissolving silver nitrate in excess silver chloride. What does it mean for something to be in excess? All that means is that we are given more than we need for our reaction to go to completion. So let's say we had 1 mole of silver nitrate, we would have more than 1 mole of sodium chloride. We have an excess amount. Okie dokie, and then the other part of the equation we need to dissect. Formation is represented by the above equation. Let's take a look at this equation over here. We are saying that for every ion of silver combined with every ion of chlorine, we get 1 molecule of silver chloride. So the first thing I'm going to do, I'm going to get my beaker and I'm going to draw some water in it. And then I'm just going to go and draw my ions. Silver nitrate will completely decompose into silver ions and nitrate ions. And as I'm sure you're aware by now, it is the same for NaCl. That will completely come apart into our positive sodium ions and our negative chlorine ions. So I'm just going to draw those ions in my beaker. And let's take a look at this. I have 2 silver ions and 2 nitrate ions. Okay, again, that's a 1-to-1 relationship. For every mole of AgNO3, I get 1 mole of silver ion, 1 mole of nitrate ions. And importantly, I have 3 ions for sodium and 3 ions for chlorine. Why do I have that? Well, because I have excess NaCl. So I have to be showing that I have an excess amount in my beaker. Now that we've set all this up nicely, our dissolved ions, let's go to the second part of our problem. Here I'm saying that for every silver ion that reacts with a chlorine ion, I get 1 molecule of silver chloride. So let's do that right now. I'm going to remove 1 silver ion. I'm going to remove a chlorine ion then. I can remove another silver ion, and then I can remove another chlorine ion. And so what is that stuff going to be forming? It's going to be silver chloride, which is a solid. And just in case you forgot, you know it's a solid because it says it right down here, solid. And so then I have to make sure to indicate that this is actually my silver chloride solid. And so let's see, what do I have left floating around here? I have the same amount of sodium ions, the same amount of nitrate ions, because those are spectator ions. They were never even used in the equation. But super important that you see this, I have one chlorine ion still remaining because I started with an excess amount of chlorine. So just really make sure you know that the relationship between starting with something in excess, having it react with something else, but then I'm still left with some of it, you get the drill. All right, that was a really hard question, but with practice, they're gonna get easier. Let's do one more example. Pictured below are two solutions of dissolved lithium chloride with an equal volume. Which of the following solutions is more concentrated? So there's a couple of things I can discern from this. First of all, an equal volume. That's going to be important later. But I mean, if you ever see something like that in a question that sounds important, just highlight it. It's going to be important. Which of the following solutions is more concentrated? That's important because that's what I'm trying to prove here. Which solution is more concentrated? What is the same thing as concentration? It's molarity. What is the equation for molarity? Moles of solute divided by liters of solution. What do both of these solutions have the same? Liters, because they both have an equal volume. So they will have the same amount of liters in each one of these beakers. So which one is more concentrated? The one with the highest molarity is just going to be the one with the most moles. So let's just count that up. Let's assume that every ion represents a mole. It doesn't really, but all I care about here is ratios, because it's not asking me to solve for specific molarity. It's just asking which is more concentrated. So over here, I've got 2 lithium ions and I've got 2 chlorine ions. So let's just say I've got 2 moles of lithium chloride in this one. And this one, counting that up, 1, 2, 3, 4, 5, 6, I've got 6 moles of lithium chloride in that one. So which one is going to have a higher molarity? It's going to be our beaker on the right. That's going to have the highest molarity. And yeah, that question was a lot easier than the one that came before. But to summarize this video, particulate models aren't exactly hard. You just have to keep in mind the rules about solubility and make sure that you're reading these problems closely to identify what it actually wants you to draw, identify your actual reactants, and also, if you have chemical reactions happening, just make sure you're paying attention to that. And with that being said, that's absolutely everything you have to know about the representations of solutions for your chemistry class. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, just take a break and come back later. Thank you for watching.